Hey guys, it's time to develop some sort of a tube vise and collet system for this new machine, so let's get to work. Well, it looks like it's that time again, and you guys come back for your weekly dose of punishment on watching me struggle my way around Fusion 360 here. But we're getting closer. I mean, this is starting to look like something. So I think today, before I start stylizing and doing the fillets and whatnot, need to work a little harder on figuring out how we want to do the tube vise, figuring those dimensions out and whatnot. So now this is a tube we're working on producing. Maybe it's produced by now. I don't know whether it's in full production or not. Let me see if I can get it to focus, but I gotta hide behind it or it won't focus. But it's an adjustable cartridge grip, so I know that I need roughly 65 millimeters between the back end of this tube to the top of the cartridge, and that's with the needle plunger fully depressed. So that's what I want for my minimum, and then there will be some adjustment in the tube chuck that'll allow the tube to go forward or backwards if it needs to, and then with an adjustable grip, you have additional adjustment. But 65 millimeters is kind of the number that I like to work with when I'm designing stuff. So that means I need at least 65 millimeters of pusher bar that's going to make it down into the tube. So let's go turn on our analysis here and get the right angle view. And we know that this is all the way down into its lowest position with the cam right now. So we need at least 65 millimeters here. And let's turn on the motor. I don't see that there. Okay, so there's the motor. Now, because the way we're manufacturing this, it's going to be, the tube will be able to slide all the way up and actually make contact with the motor, which is not a good thing. So we don't want it to go that far. So we'll probably build in some limitations farther down, because if not, I guarantee you some jackass is going to cram a tube as far up in there as he possibly can and then try to run the machine and break something. So I don't think I can. I suppose I could build in some sort of a limitation here. I could put in a little press pin or something that won't allow that to happen. I'll deal with that later. Just something that's going through my mind right now while I'm doing this for future consideration. I need to think about it. So let's see. If I remember right, we built the lower leg of this pusher bar to 10 millimeters, and we know we need at least 65. So let's just simply grab this and extrude that down, and let's go, we'll add 60 more. There we go. We have a nice long bar, and we will put a small tube on the end of that, or ball on the end of it, or cylinder with a radius end. I'm not sure yet. We'll figure that out when we get to it. So give me 1 second. I'm going to, what do we got over here? Mm, mm. Where was I? No, no. We'll just wing it. All right, we'll go back to this project envelope here. Come on. No. All right, we'll stay in here. What we'll do is we will just start a new one here, save, overhead to save. It's just untitled. Let's do a sketch on this axis. We're going to go with a circle with 8 millimeters. That's what we got to do. We'll change this to units, millimeters, just for giggles. And let's see, what do I usually shoot for in an OD or an ID? Say 5.5 millimeters inside diameter on the. Okay, so there's our tube. We are going to just simply get out of that and extend it down in this direction, negative 65. There, that's our tube, and will represent our depth we need to the top of the cartridge. So let's rename it tube stem. There we go. And we'll save that quick. User saved is fine. Get out and insert it into the new design. Where do we want it? We want it. Oh, let's go down. Let's go over. Let's just use one of our favorite tools of align. And we shall turn off our analysis. We're just simply going to align the center of that with the center of that. There we go. And, oh, where do we add that? Oh, we added at the pusher bar. Let's not do that. Drag tube stem up to the whole project, capture position, break link, and come on, break link. Does not want to break link. Don't care. All right. All right, so this represents the length of tube needed. This is for your standard off-the-shelf tube, either be some sort of click grip, adjustable grip. My chair's not where I want it, excuse me. Disposable grip, things like that. We're just trying to be general here. If we can we have to adjust that, not a problem to go back and change the length on that pusher tube. But let's see, what is a typical clamping length on a tube is probably around 3/4 of an inch, 19 millimeters. So we'll leave that link open actually, and we will construct a plane negative 19. So that would be sort of the top of the gripish. Let's just draw on that plane. See, 25 millimeter grip finish. Sure, 45 millimeter grip. Oh, hey, we cut again as opposed to join. Join could have been a new body because it would not necessarily be attached. All right, let's just make it a little more appealing here, and we will go with a 8 millimeter radius. There, now it looks kind of official. We'll save that and close it. Now over here I've got this little warning up top telling me that one of the components associated with this design needs update. So I'll just click that little thing and bam, we have a grip. All right, so honestly, we can, if we go to our right side and we turn our section analysis on, okay, we can bring that up in there because that looks a little overextended to me. So let's go to pusher bar, and I believe it's going to be this extension. Let's take that down to 50. All right, and we got that. So let's, that's how we'll keep people from jamming the tube so far up in. We'll make sure that the bottom section of the tube clamp section is more than 19 millimeters from the base of the motor. That should work in most circumstances, and we'll probably add, we'll add 6 millimeters on that. So we'll go up to a full inch away, and that should solve that problem. But anyways, let's turn off our analysis and let's use our align tool again to basically section that there to there. Okay, turn the tube back on. Right side view, analysis, and nope, now there's the problem I was talking about. So here we go. We are going to simply go, we're still in the pusher bar, back to that. We're going to go to 55 millimeters, and we are just simply going to take the tube stem and we're going to move that down 5 millimeters. There. So that is kind of about as deep as we want the tube going up in. If not, it'll start to encounter the bend in the pusher bar. So this is the space we have to work with. And I'm going to work, so what do we have here roughly? Always measuring. From that surface to, let's say, that surface, we have a total of about 15 millimeters. So I would physically like to add 15 millimeters to the machine down to the bottom of the tube vise. Not that I want to add that much more space, but if doing so helps reduce other problems farther on down the road, it is worth doing. So we will simply start. Let's hide that. Quickest, I got capture position on things. Motor housing, because that's what we're physically working on now. Let's grab this and we extend this 15 millimeters. It won't look like that, but it just gives me a visual representation of the space that I'm willing to work within. Oh, let's see. There's our key right there. We will give me a minute. I'm thinking. Not going to have a full 8 millimeter passage going all the way up through there. It's actually Oh no, I am. I'm not building a cartridge dedicated machine. Well, a fixed grip pen style machine. So I'm not going to reduce the cavity down to an eighth of an inch or 3 millimeters because that's going to be done in the production grip itself. So it's hard to keep all these things jumping around in your mind. So this is where we want to be for the base of the machine. So let's fatten this up. This taper probably is going to go away for the most part. What is the radius we're working on up here? 27.7192 millimeters. That's an odd size. Okay, I can work with it. So probably bring that down to, geez, need a visual reference here. Probably around a 19 millimeter diameter, so 16 millimeters sounds fantastic. So I'm going to, let's see, I'm just going to add a lot more material and then I'll reduce it as needed. So let's add this out to 19 millimeters. Bam. Finish sketch and extrude this up. See? Gotta look at everything from every angle on a regular basis. So this is, if I push here, then I'm going to be pushing the rear boundary of my machine. Now what's going to be more important to me? Maintaining a specific diameter on this tube vise or adding a 0.5 millimeter to the back of my machine? I don't know yet. I may try both ways. So for now, for convenience wise, we're going to stick that in there. God damn it, it cut again. And that's okay because guess what? That sketch was not where we wanted it. That sketch is supposed to be in motor housing, and I'm supposed to be working in motor housing. All right, so let's change that sketch. All right, Mark, where'd you drop that sketch? No, it's still there. In the motor housing. There we go. Now, all right, let's back that down to 18 millimeters for the sake of argument and not protruding up into the backspace of the machine that we kind of already designated where we want it. Left side, let's turn it up and let's pull this up. Ooh, that blends nicely. Let's go 21. And we cut again because I don't know why it keeps defaulting to cut. I want to join. Okay. There we go. We have now extended the base of our machine down to where we want it to be. I may neck it down a little bit, which let's do that. Let's go to this. Let's go to 19 millimeters. Negative 19 millimeters, no. Negative 16 millimeters, no. 14 millimeters. It's not pretty, but let's just, let's go with that for right now. Looks a little weird, but it won't once we add some fillets in there. Because if you take and you do something like this and you add an 8 millimeter fillet, it won't work that way. Let's delete that line. Grab this one. 8 millimeter fillet. Okay, we'll call that, and now we have a new line here, and this new line we go with an 8mm fillet. And we can neck it down, or let's go with 6 or even 4. We can make it pretty later, so I'm gonna get rid of that now. What are we gonna have here? We're gonna cut some threads into this. Let's put a chamfer on the front first. Okay, chamfer this. We'll chamfer a full millimeter, 1.5mm. Chamfer. We will all right. Let's back up to this again. We're going to go to 10mm, negative 10mm. There we go. And then from here, we will create a sketch on this plane. Look at it from the other side just because it's a little more convenient. We know that's our center. No, we do not know that's our center, is it? Stop rushing, Mark. Okay, so there's our center. So then we're going to go, oh, where do we want to be? I know that's 18. I don't know what that is. Let's get down to 14mm. Let's extrude that up. Just going to bring it until it merges the edge there. Good. And it's going to cut again. The joys of this is amazing. Okay. All right. It usually wants to default to new body, and for some reason it wants to default to cut these days. All right, so that looks just a little sexier, if you ask me. Okay, so let's throw a thread on this part here. It's going to automatically know that it's 18mm, so 18.25 is a standardized thread, blah, blah, blah. Let's model that thread on there. That looks a little too coarse for me. Let's get on to a 2mm thread. I like that better. Okay. And you know what? We're going to go backwards in time before that thread, and we are going to put a chamfer on the back side of this. Just a simple one, little 1mm. And now we're just going to extend to the ends of bringing it. So now we have a thread. And let's see. We're going to need to create a conical taper in here because we're going to use sort of like a collet style clamping mechanism on this. So let's do this. The best way to do this is let's create a new component. Oop, not all the way up to the top. All right, so new component, call this collet cavity. Okay, we are cruising now. Okay. Just for giggles, I want to look at that line there. 7.5mm radius, 15mm diameter. Okay. So from the front here, I'm going to have let's draw a sketch here. So we got 15mm, leave them at least a full millimeter wall. So we'll break that down to, we'll go 14mm outside diameter at the bottom. Let's draw a sketch on this plane. here we are going to project. We're always projecting stuff. We're going to just project that line there. Okay, and we are going to, we're going to draw something that goes from this line up closer, across there, down there, and over there. Okay, so this is kind of what we're going to work on here. So we're going to align the midplane of that line we just drew with this. No, what happened there? Let's get rid of that. Let's make that a construction line. And let's put an actual point on this line, just so I physically, that's the midpoint of that other line. I want to know what the distance is from here to here. And I want to put, all right, focus mark. Let's put a point up here. Point on that midplane. Why am I not getting? That's straight down. I don't want that. Let's completely discombobulate things here. All right. It's because it's. I'm going to delete this for now. Delete those constraints for now. Okay, so now I should be able to pull this down, pull this down. Let's connect these. That's why there was no line. Okay, let us add a midpoint to this line here. And we need to make sure that this point stays centered over that point. Why? There. Okay, so okay. Now we're going to make sure, oh, you know what? Let's do this. Let's constrain this midpoint to there. All right, so now we're in alignment. Now we're going to constrain this and off of there, not tangent, constrain this point to that line. And we are going to make dimensionally this line here. We said 14. Well, that got wonky. This line is going to be equal to this line. And let's see, 14 millimeters might be a bit much there. Let's go to 13. Let's bring that in. And we don't want too steep of a cone angle. And I want my cone to have a pocket to sit in up here. So up here we know the tube is 8 millimeters in diameter. We're going to dimension this out to be 10 millimeters wide. And we are going to, the only other thing we need is a dimension from this line to this line. And I'm thinking 16 maybe. Okay. That's a decent collet angle, I think. I'm just kind of guessing off the top of my head. We can always adjust things as we go. Okay, so that is the dimension of the collet. For fun, or not even for fun, we're going to make use of it. We're going to draw a center line and what else do I want to do here? I'm going to name this sketch collet profile, and we're going to use that for a number of things. So we're actually going to, I have a very weird idea, well, maybe not a weird idea, but we're going to let's make that 3 millimeters. Sounds good. And we are going to also constrain this corner to this corner. Now that sketch is fully constrained. Okay. We'll just make another one. There we go. Okay. So let's do this. We're going to, let's find out what this angle is. Let's open the sketch back up. I need to measure what this angle is to this angle. Measure, angle, line, and 10.7 degrees. I'm not going to find a 10.7 degree tapered end mill. I could have one custom made, but that doesn't make sense. So let's do this. Let's take this. I'll take this dimension out. Okay. Excuse me. Come on. Put 16 back. Let's just delete that dimension. Okay, so now our sketch is not fully constrained, but what we're going to do is we're going to dimension that angle from here to here. And let's make that a 12-degree angle. There we go. Because I can easily find a 6-degree tapered end mill to cut that taper in one pass. I'll bore it all the way through, cut the taper around the outside, and I'm done. So now I can finish the sketch. And what I want to do here is I'm going to revolve this around this, and it is, this time I do want a new body, okay? I'm going to do 2 different things with this. That new body is going to serve 2 purposes. It's not only going to be the main shape of the material. Hey, that's not in where we want it. Okay. I should have been drawing that on the centerline plane with the needle bar or the cavity. So not a problem. What we'll do is we go back in time. You can do that with CAD, and we're going to create a sketch. I'm going to create an offset plane, which is going to be this face plane, and we are going to create that plane object. Let's see, what is it going to let me grab here? Let's look at our pusher bar sketches, turn that on, and let me just see that it is in fact doing what I think it's doing. It's going to push it. Oh, we know where that is. Yeah, -4. Okay, so that now is running straight down the center of that needle bar. Okay, all we have to do is go forward we're going to reposition this sketch plane onto there, and it's going to shift everything over. It pushed it up 1.5 miles. Weird, but not the end of the world. Well, I don't want appearance. The wrong A word. I want a line. And I'm just simply going to align this face with this face. And I'm back where this is where I wanted to be. But guess what? It's 180 degrees wrong. Let's just do it the right way, Mark. Okay. I'm going to grab all these items. No, not all of them. Why are you showing me everything? I'm not in the whole thing. Oh, because I'm not in the one I want to be in. This is... Oh, I'm in collet cavity. I don't know why it's showing me everything else. Needless to say, we'll just turn all of these off. Everything is off. Motor housings off. Why that sketch is still showing is really weird, but I can work with it. Okay. I'm going to grab this stuff here, and I'm going to move it. I want to rotate it. I want my axis to be... You know, let me pick a point. No, you're going to want an axis, actual axis. All right, origin. There we go. Stuck again. I got too far ahead of myself. Let's just... That's pretty much what I want. Except for it's reversed. So let me Control Z, Control Z, Control Z, Control Z, Control Z. Let's go back a little bit here. Grab these items. I'm going to hit move. I'm going to rotate. And I'm going to run there. And we are going to go. This stuff here should not be here. All right, I don't have the patience for that right now. So we're going to take all this. We are going to copy that sketch. We're going to finish that sketch. Guess what we're going to do? We're going to delete the revolve. We're going to delete the sketch. Now that we're actually working on the right sketch plane, we're going to start over again. We're going to, there's our sketch plane. Yay, me. Okay, we are going to Control V, right? Sketch on this plane, Control V. It's not giving me my sketch. All right. Well, guess what? We kind of know what we're doing, so we'll do it again. And you do this a lot when you're designing something. Just sometimes things don't go the way you want them to. So, okay. Fat end down here, thin end up here. There's our collet. Let's do some dimensioning. Top end of the collet, I think we went with 10 millimeters. Bottom end of the collet, I think we went with 13 millimeters. Okay, we're gonna add a couple of points along the middle of that line and along the middle of that line. We're going to constrain this point to be directly over that point. And there, ooh, don't do that to me. We're going to constrain this to be here. And we're going to constrain this to be under there. Then I believe we eventually constrained this and this to be 12, and we definitely need this side to be equal to this side. And I want to say we projected this line up here, and then we constrained this point to match this line. Everything's easier the second time. Okay. And then we threw this 3 millimeter rectangle up there. We're going to constrain that to this. And we drew a line from here to here. We're going to extend that line up to the top, and we're going to call that sketch done. Now we're going to revolve this and this around this center line. Okay. Quick and easy once you've done it. So that, oh wait, did we do new body? Okay, it was a new body. Okay. This serves two purposes. Okay, what we're going to do here is we are going to modify, we are going to do what is called a combine, but it's not really combining. We're going to cut, tool body is going to be the cavity. So let's turn off the motor housing for a minute. We'll select that. And target body that we want to cut is going to be the motor housing. And we're going to keep the tool because we want to use that a little bit later. And okay, so now we're going to hide the tool. Hey, guess who still doesn't have an alignment of the collet? And who didn't think to double check it because in their mind, they knew they did it correctly. Good stuff. Okay. Let's go back to resolve. I want to look at this sketch, and we're going to go right. And that plane is not where it wants to be. Not a huge deal. Let's redefine the sketch plane to here. Okay. Okay. There we go. Should be fine. Let's go to our motor housing, turn it on. Let's turn off the construction and the collet cavity. And in theory, I did the combine in the wrong place. Collet cavity, it's not there. It should be in the motor housing. Let's get all the way in. Oh, there it was. No, it just wasn't showing. Okay. Not sure if you can see that properly. It's definitely still not centered, so there's another issue. Not a big deal. Well, we're centered around that. So what's not centered around it is our or this structure not coming down? Let's analysis view. It appears that it is correct. What we're seeing is this little lip here. Actually, I like that. That allows the collet to have a seat, a place. Because we're going to bore this from the bottom side. We're going to bore the 8mm hole all the way up through. We're going to bore the cone from below. We leave this ledge, then the collet can't wedge, just continue to wedge. Because once it wedges up so far and gets so tight, it's going to be an absolute pain in the butt to get it out. So that lip is kind of like a little bit of a unforeseen blessing, I guess you could say. So happy mistakes, Bob Ross, whatever. So this is where we are at. I'm gonna call it quits. Now try not to get this too long. So we extended this down. We got the threads, needle bars about the length we needed. Everything is looking pretty darn good. I have zero issues with this at this point in time. Next time we get together, we're going to finish the collet. We're going to have to design that in a manner where it has some slots in it so that it can compress and spring back. And then we'll design the collet nut to go over the end. And to be honest with you, at that point, we're basically done, other than stylizing it with picking out the fillets, radiuses, and things like that. There's a few things I have to keep in mind when I'm doing that. I try and work with either tooling sizes I already have downstairs or things that are at least readily available. And not get too small of a radius, because if you get too small of a radius, you end up with a really tiny cutting tool. It takes a long time and extends the machining programs, not to mention they become more fragile. So this is where we're ending today. And let's turn on that tube stem. So yeah, there's where we're at. Thanks for watching and being champs and sticking it out. And I assure you, we will get this project done. And I'm really thinking I'm going to machine this. And the truth is, if you're watching it, that is where we're going, because I wouldn't put this out there and tease you guys or give away this design for somebody else to produce. So yeah, we're going to make this. I'm going to make that commitment right now. So once again, thanks for watching, and I will catch you all next time. Be sure to click the playlist and catch up on any episodes you missed while you're waiting for the next one.